All right, welcome to The Explainer. Today, we're tackling two of the biggest buzzwords in tech, machine learning and deep learning. You hear them all the time, right? They're the brains behind your social media feed, self-driving cars, you name it. But what's actually the difference? Well, we're going to break it all down for you using pizza.
Yeah, you heard me right. Pizza. And I know it sounds a little weird, but just trust me on this one. Because by the end of this explainer, you're going to see how a super simple dinner decision can actually help us understand the core ideas behind some of the most powerful AI out there today. So yeah, let's do this. Okay, first things first. Before we can, slice into our pizza analogy, we gotta understand where machine learning and deep learning even fit. Think of it like this. They're all part of the same big techie family. So, at the very top of this family tree, you've got artificial intelligence, AI. This is the big one. It's the whole massive field dedicated to one really ambitious goal, making machines that can think and learn like we do. And machine learning and deep learning, well, they're two of the most powerful ways we've figured out how to actually do that. And this is the perfect way to picture it. Okay, so if AI is the whole universe, everything, then machine learning is like a giant galaxy inside of it. And deep learning, that's an even more specific solar system, kind of tucked away inside that galaxy. The key thing to remember here is that all deep learning is machine learning, but not all machine learning is deep learning. It's a subset. All right, now for the fun part. Let's actually build a simple machine learning model to solve one of life's biggest, most important questions. Should we or should we not order pizza for dinner tonight? So the goal here is super simple. We just need a yes or no. That's it. Our little model is going to take a few different factors, weigh them out, and then just spit out a prediction. This right here is machine learning 101. Okay, so every model needs data to work with, right? These are our inputs. We're going to use three simple questions. First up, X1. Will it save me time? Oh, for sure. So we'll call that a 1 for yes. Next, X2. Will I lose weight? Probably not, especially with the toppings I'm planning on. So that's a 0 for no. And finally, X3. Will it save money? Well, I've got a coupon, so yeah, it will. That's another 1. But here's the thing. Not all of these factors are equally important to me, right? And this is a really key idea in machine learning. Weights. We get to tell the model what we care about most. So for me, saving time is a huge deal. Let's give that a weight of 5. My weight, I care, but pizza's calling my name, so we'll give that a 3. And money? The coupon helps, but dinner's not going to break the bank, so let's give that a weight of 2. So how does the model actually make the call? It's just some simple math. It takes each of our inputs, the ones and zeros, multiplies them by the weights we just assigned, and then adds it all up. But to make a decision, it needs something to compare that number to. We'll call it our pizza threshold. Let's set it at 5. If our final score is bigger than 5, it's a yes. If it's not, it's a no. Simple as that. So let's run the numbers. We've got 1 for time times its weight of 5, plus 0 for weight loss times its weight of 3, plus 1 for money times its weight of 2. That gives us a grand total of 7. Then we just subtract our pizza threshold of 5, and the final answer is, drumroll please, a positive 2. And there it is. That's our answer. Because the number is positive, our model is giving us a big fat yes. The model has spoken. It is officially pizza night. See? That's machine learning in a nutshell. Okay, so that was a great little example of basic machine learning. But what in the world makes deep learning, well, deep? What's the big deal? The very first and maybe most obvious difference is all about the structure. It comes down to layers. And in the world of neural networks, the magic number is usually 3. If a network has more than 3 layers, that's an input layer where the data comes in, an output layer where the answer comes out, and at least 2 hidden layers sandwiched in between, then it's officially considered deep. Our pizza model? It was super shallow, basically just one step, a single calculation.
So yeah, a deep learning network has all these hidden layers stacked up. And you can think of it like an assembly line. The first layer might spot simple things like edges and colors. The next layer takes that info and looks for combinations like shapes. The layer after that looks for even more complex patterns like textures or objects. It's this layered hierarchical approach that lets these models understand really complex stuff, way beyond what our simple pizza calculator could ever do.
But, the number of layers is really only half the story. The other difference, and honestly, this is the one that's a real game changer, is how they learn. and more specifically, how much handholding they need from us humans. So a lot of traditional machine learning is what we call supervised learning. It needs a human expert, a teacher, to go through and label all the data first. We have to sit there and tell it, okay, this picture is a pizza, this one's a burger, this one's a taco. It's a lot of work. But deep learning, it can act more like a detective. With unsupervised learning, you can just dump a massive pile of raw, unlabeled data on it, like thousands of random food pictures, and it will start finding the patterns all by itself. It figures out what makes a pizza without anyone ever telling it what to look for. It's pretty amazing. Okay, so let's pull all of this together. We're going to wrap up with a final summary of the key things that really separate these two amazing technologies. But before we hit that final summary, there's one more cool concept we gotta touch on: how these networks actually get smarter over time. So making a prediction, like our pizza model did, is called feed forward. The data just moves in one direction. But the real magic trick is something called back propagation. Imagine our model said no pizza, but we went ahead and ordered it anyway. The model can see that it made a mistake, and it can literally work backward from that error to tweak its own internal weights. It might decide, I guess I should have made time saved even more important. It's this incredible self-correcting loop that allows these things to learn. So let's put it all together in one simple table. It really boils down to two main things. First, the layers. Your standard machine learning is pretty simple, maybe 1 or 2 layers, like our pizza model. Deep learning is way more complex, with more than 3 layers. And second, how it learns. Machine learning usually needs a human to label the data. That's supervised learning. Deep learning, on the other hand, can often teach itself using raw, unlabeled data. That's unsupervised. And that really brings us full circle, right back to where we started. It's not about machine learning versus deep learning. They're not competing. It's just like the quote says. Put simply, deep learning is a subset of machine learning. It's just the next step, a more powerful evolution built on the very same ideas. And there you have it, the difference between machine learning and deep learning, all explained with a slice of pizza. It's really the difference between a simple, rule-based calculator and a brilliant, self-teaching detective. So now that you get the basics, I've got a question for you. What's an everyday decision in your life that you would build a model for? Think about it. Thanks so much for joining me.